At the end of the lesson, you are expected to identify the challenge of overflow and underflow, determine the method of stabilizing overflow and underflow, and appreciate the significance of stabilizing underflow and overflow. In computation, one of the fundamental challenges is representing infinite numbers with finite ones. So in other words, approximation error really happens. And this is especially true in rounding error case. So I am sure you are already oriented with rounding method. That is very elementary, but then for the sake of this discussion, I would like to give you an example. Okay, so 9.5, this becomes 10. 9.4, this becomes 9, right? So this is actually basic or elementary in mathematics, how to round up and round off or round down numbers. So we have two kinds of rounding error. So these are underflow and we have overflow. So what does each one mean? When does each one occur? So when we say underflow, it occurs when numbers that are near 0 are rounded to 0. For example, we have negative 0.00017. So as you could see, this number is actually very close to 0. So this is rounded up to 0. So this happens when we try to avoid dividing a number by 0. So this happens also when we try to take the algorithm of 0. So in this case, we treat it as negative infinity. Let me write it here. So this is negative infinity. Okay, so that's a symbol of negative infinity. Now, we have the second kind of a rounding error, and this is called overflow. So maybe you want to ask the question, when does overflow occur? So it occurs when numbers with large magnitude, let me underline that, large magnitude are approximated as infinity or positive infinity, or it can also be negative infinity. So if we are going to follow these two methods, then our algorithm will fail in practice, even if in theory it works. So what shall we do then to ensure that both in practice and in theory, these two really work properly? So in this case, you're asking me, how are we going to stabilize our computation then? Okay, so to solve the rounding errors, we're going to stabilize them using the softmax function. So what is the softmax function? What is this all about? Softmax function is used to predict probabilities. So these probabilities can be associated with multinomial distribution or multinolly distribution. So it is defined by this formula. So we have softmax xi is equal to exponential xi over summation exponential xj. So let me note that xi is equal to a constant c. Let me write here. So xi is equal to a constant c. So in this case, c is very important because if c is negative or very negative, then exponential c will underflow. Let me write that. C is very negative, then this will result to underflow. Okay? So it means that the denominator of the softmax, this case, the denominator, will become 0. Then the outcome becomes undefined. On the other hand, if c is very big and positive, let me write here, it is big or very big and it is positive, what would be the case then? It's the opposite of the first situation. So in this case, exponential c will overflow. Let me write that. Overflow. Okay. So what does it mean? Like the very negative situation, this will also result to undefined. So both very negative and big or large number, which is also positive, are both undefined. So that is really a problem, because in computation, we would like to get something that is specific, something that is concrete, something that is real. But in this case, the situation resulted to is undefined. So that is really a very big problem, especially if we would like to predict how can we describe something that is undefined. So in this case, we need to resolve the problem. So we're going to evaluate softmax z. So we have here. So the first thing that we will do is that we're going to transform x into z, which is equal to x minus max subscript I x I1. So why should we do this then? So this results to exponential being 0. Okay, exponential being 0. This rules out the possibility of overflow. Okay, so this also makes the denominator to have a value of 1, and this results to ruling out the possibility of underflow in the denominator. So this does not actually affect the output. So later we will have that. We will understand more about this. So to understand what I'm talking, let's have this. Okay, so softmax z I is equal to the exponential of xi minus c. So as you could see, the constant c here we have added here. So, and what we do here is that we subtract the c from the xi, and then over exponential xj minus c. So it's still the same case, right? So in this case, what we will do is that we're going to cancel the constant, and to do that is that we're going to do exponential, or to add exponential of c. So for the numerator and also for the denominator, so canceling them will give us exponential xi over the summation of the exponential xj. So with this, our problem of overflow and underflow is solved. So now we have an element with value 0, or exponential 0, which is equal to 1. This means that at least one element in the denominator is 1. So as you could see, this is actually the value, the exponential value of each variable or each number, then over to the total exponential value of all the variables, or all of the values. What is this for? Why do you have to study this? Softmax function is used in many multi-class classification methods. Among them are multinomial logistic regression and artificial neural networks. It is used in the first layer of a neural-based classifier. In reinforcement learning, a softmax function is used to convert values into action probabilities. After all being said and done, let's try this. When does overflow occur? When does underflow occur? How can overflow and underflow be stabilized? Leave your answers in the comment section below. Do not forget to subscribe, like, and share. Please click the bell button to be notified every time we have a new session. See you in the next lesson.